Welcome to the next video in the Home Yeast Lab Made Easy video series. In this video I'm going to be showing you how to prepare two different kinds of agar plates, both of which can be used for culturing either yeast or other brewery organisms like lactobacillus and pediococcus in your home. So everything you need for these I've laid out on the counter here. The stuff shown in this particular frame is the stuff you need regardless of what kind of media you're making. So you're going to need petri dishes, a flask or something else to prepare your media in, an alcohol lamp or Bunsen burner, and obviously something to light it. And you're going to need agar. And I know some people think agar is hard to find. It's actually really easy to find. You can get food grade agar online or in health food stores because it's sold as an alternative to gelatin for vegans. Now the first media is probably not going to be too big of a surprise to anyone watching the video. That's shown here. All you need is one of these two things. You don't need them both. But what we have here is about 2.5 grams of dry malt extract. Or alternatively, if you have prepared starter wort or maybe wort from a beer that you've prepared, you can use that instead. And obviously we're going to use that to make a wort-based agar. But to the right here, we have the second media. So here's the stuff for making the second media that I'm going to talk to you about today. Obviously it's a little bit different. Here in front I have a little bit of dextrose or corn sugar. If you don't have this, table sugar will work fine. And I have a potato, but we'll get back to that potato as well as that blowtorch hiding in the back there a little later on in the video. So if you purchase the plastic petri dishes, they come pre-sealed in packs of 25 and these are sterile. So as long as this bag is sort of kept intact, the plates inside stay sterile. Now when you open these, it's really important to open the right part. If you look here, you can see this plate. There's the lid facing down, and there's the bottom of the plate, the part that's inside the lid on the top. And this is the end of the bag that you want to open. You don't want to open the other end where the lid's on the top, because as you'll see in a second, that makes it almost impossible to get these plates out in a way that keeps the plates clean. So just open the bag with a pair of scissors and cut that top right off. Now to get these out of their package sterilely is simple, but it's important you do it correctly. So you can see here I have 4 dishes in here. If I only want to get one out and leave the rest in here and keep them sterile, it's important I remove that one particular dish without opening up the other one. And so to do that, put your one index finger at the base of the plate you don't want to remove, and then grab the other one by the lid. That way you can pinch this one shut while holding these ones closed, and you can get that out without contaminating either the plate you're removing or the plates in the bag. So this bag can now be resealed and reused in the future. So if you decide to go the route of using glass plates, you are going to have to sterilize them before use. And this is luckily quite a simple thing to do. Just take some tin foil and wrap your plates in them, and do it when you're sealing these packages. Make sure you're folding the edges over twice to get a good seal. You can wrap plates either individually like I'm doing here, or you can stack 2 or 3 of them together and wrap them that way. It doesn't matter. And we can then, once we have these wrapped up, place them onto a cookie tray. And we're then going to place this into the oven at a high enough temperature that we can get what's called hot air sterilization. So we'll go to there in just 1 second. To sterilize these plates, place them into a cold oven and then set the oven to 175 Celsius or 350 degrees Fahrenheit. Once the oven comes up to temperature, set a 1-hour timer, and at the end of that time period, remove the plates from the oven. This is sufficient to sterilize them completely, and as long as they remain in those foil packets, they'll remain sterile until needed. So the first media I'm going to show you how to make is wort agar, which as the name suggests is just solidified wort. Now we could start with maybe some wort we prepared for a starter or pulled off of a beer, but today I'm just going to show you how to do this from dry malt extract as well as obviously powdered agar. If you go to the blog post that accompanies this video, I'll have instructions for how to do this from wort. So what we need is wort that's fairly dilute. We only want it to be between 1.002 and 1.006. So if you're working with dry malt extract, that's 2 to 3 grams of dry malt extract into 100 mils of water. So this is going to make a fairly dilute solution, somewhere around 1.002, 1.003. So we'll put that in there, We'll mix it in as good as we can. We don't have to worry about getting out all the lumps because obviously when we heat this, that'll take care of everything. Now the next step is to add the agar. And adding agar is a little bit more challenging than the dry malt extract. It has a tendency to clump, and we really can't afford to have any clumps because those will just form large lumps of agar. When we heat this, they'll stick together, and as a consequence, it would ruin our plates. So when we add this, we want to make sure we're adding it, a little bit at a time. Make sure the water you've used is cold, and we just want to make sure that that water is always moving as we sprinkle this stuff in. That way it won't clump. We'll get a nice even distribution of it. There we go. And this should now turn into a nice media. Now the last thing you can add is some ferment cap S. It's not required, but I really like this. One is that obviously it's going to help us with boilovers, but the other thing that it does is it keeps a lot of the proteins from aggregating, and so you end up with clearer plates. So it's easier to see colonies, especially small colonies on these plates. And a single drop of this is a huge excess, but it's obviously the smallest amount we can conveniently do, so put in a single drop. Lastly, if you were trying to grow some fairly weak yeast, something that wasn't very robust, you might even want to think about throwing in a little bit of yeast nutrient, but 99% of the time, that's not necessary. So next we need to sterilize the wort. Now if you have a pressure cooker, you can achieve complete sterilization fairly simply. Take your flask, put it in the pressure cooker, and put as much water into that pressure cooker as you can without the flask floating up and tipping over. Put the pressure cooker on its highest pressure setting, bring it up to temperature, and once you get the full pressure and full temperature, let it go for 15 minutes. You can then remove it from the heat, and once that wort cools down to about 65 degrees Celsius or 145 Fahrenheit, it's ready to go and you can now pour your plates. But you don't need a pressure cooker. In fact, I never use one. All you need to do is bring this to a boil on your stove for about 5 minutes. And it doesn't even need to be that vigorous of a boil, just a gentle simmer is enough. This is actually enough to kill off most of the things that would grow in the media. And the few things that survive don't do very well with oxygen, so they're not going to grow once you pour your plates, because of course their plates are exposed to the air and therefore there's oxygen. Now that said, if you do a bad job pouring your plates, if you don't use good aseptic technique, you can still end up with contamination, but that'll happen whether you're using pressure cooker wort or wort you just boiled on the stove. So next we want to pour our plates, and to do this we need to first let our media cool till it's around 65 Celsius, 145 Fahrenheit. If we pour the media when it's too hot, it may crack our glass plates or melt our plastic ones. Obviously if we let it get too cool, it's going to solidify in the flask. Now you can determine this using a laser thermometer or something like that. I've been doing this for a while, so I can just kind of go by touch. I know when it's sort of uncomfortable to touch but it doesn't burn you, it's about the right temperature. So when we pour plates, we need to use proper aseptic technique, which of course means working near a flame, in this case an alcohol lamp. And if you don't know how to do this, or if you don't know how to make an alcohol lamp, I have videos for both aseptic techniques and alcohol lamps already up. So to pour a plate, we obviously need to flip it over so the lid is up. And we then want to remove the foil from our flask. We want to flame the lid just to make sure if there's anything on there. We kill it, and we want to lift the lid the minimal amount possible, and we're going to pour slowly, trying not to make any air bubbles until we get the right thickness. And I'll show you what that is in just a few seconds. But it's about 30 mils per plate, so from 100 mils you're going to get 3 to 4 plates. Now I'm going to sacrifice this second plate just to sort of show you that pour in a way that you might actually be able to see. And I'm deliberately going to create some bubbles to show you how to fix those. So again, we're going to just quickly flame that. And so when we pour, you want to be as close to the plate as possible so you're not splashing. And you want to pour slowly so you don't get bubbles. If you're too high up, or if you pour incorrectly, you're going to end up with a lot of bubbles on your plate. And this really ruins the plate because now it's going to be hard to get even spreads of our organisms. And so this is where trusty old blowtorch comes in handy. So you just want to hit the plate up very briefly with a little burst of flame, and that'll pop those bubbles, which obviously will now clean up the plate. Now you don't want to do this too much because that'll melt your plate or it'll shatter your glass. And obviously if this was a plate I was going to keep, I would be doing that with the lid in place so that we're still keeping that surface clean. And you can see there I overdid it, I melted the plate. So how do we know if we've poured enough media into the plate? And this actually isn't as hard to figure out as you might expect. If you look here, you can kind of see that the top of the media falls roughly along where the edge of that plate is. And that's a good sign you have the right amount. It's 25 to 30 mils, but rather than measuring that exactly, you can just pour until the top of the gel is roughly even with the bottom of the lid. So once you've done pouring your plates, you just want to let them sit on the counter for about 20 minutes until the gel solidifies, at which point you want to immediately flip them over, because as you can see there's a fair amount of condensation on the lid, and if we were to just leave this, this would drop on the plate and ruin it. So after about 20 minutes, the gel will be hard enough that you can flip it. Now obviously it's quite important you don't do this too early, and again I'll show you this with my sacrificial plate, but yeah, if we flip them too early, as you can see, it just spills out everywhere and makes a mess. So that's how you would make wort-based agar, but what about this potato that I've been lugging around? Well, I'm going to use this to make a classic media from microbiology called potato dextrose agar. This is often used for growing bacteria such as lactobacillus and pediococcus. It's also used for growing fungi, which would include yeast. And the nice thing about it is it's dirt cheap. I mean, you literally need potato and corn sugar to make this. So what you want is about 50 grams of the potato, which isn't very much. Look at that, dead on 50 grams. I'm getting good at this. We're then going to shred this, add a cup of water, bring it to a boil, and let that simmer for 20 to 30 minutes. At the end of that period, you want to filter this through a fine mesh sieve. If you want to go a little bit farther, you can run this through a coffee filter after. The first filter should be through something a little more coarse so it doesn't gum up. This should give you about a cup of filtered potato extract. You need about 100 mils of this, and to this you want to first add and mix in the dextrose, the corn sugar. This will dissolve quite quickly into the hot liquid, and it's then ready for the addition of the agar. Now the agar you need to add quite slowly. It'll clump really readily in this hot liquid, and if it clumps, it's going to be very hard to get smooth plates. So swirl constantly, add it slowly, and you should be able to blend it in without significant lumps. Once everything is mixed, bring this to a boil for 5 minutes, or sterilize it in your pressure cooker, and then pour the plates just as I showed you with the dry malt agar plates. So it's been a little under a week since I prepared these plates, and I just want to show you the difference in growth between beerwort agar and the potato dextrose agar. So here on the left we have beerwort agar. We have at the top Saccharomyces, so this is just WLP001. Here we have Cloacachera. This is an oxidative yeast that would be present at the beginning of a lot of wild ferments. At the bottom we have Brettanomyces. This is just the Y yeast, Brettanomyces bruxellensis. And on the left we have Lactobacillus, and again this is the Y yeast Lactobacillus. So I'm just going to flip this plate over here so you can get a better view of the growth. And I think what you might appreciate is that while there is growth on each quadrant, the growth isn't that intense, it isn't that thick or florid. So these plates do work really well for growing these organisms, but the growth is somewhat slow, and it's not quite as aggressive as we might see in other plates. And I think you can appreciate that just by looking on the top side at the potato dextrose agar plate here, which if you recall I cast on the glass plates. And so here we can see Saccharomyces, Cloacachera, Brettanomyces, Lactobacillus, same source, same size loop, so the same volume of cells were plated down. And you can just tell from the back side there's a lot more yeast growing, or bacteria as well, growing on each of these. And so here you can see I did a pretty bad job streaking out the Saccharomyces, but there's still quite strong growth, and there's quite strong growth on all the other quadrants. So aside from being cheaper, the potato dextrose agar actually gives us better growth under a lot of conditions. So just lastly, I want to show to you that these plates are in fact clean, even though I only boiled these medias for 5 minutes. And so here is the other potato dextrose plate I made. You can see from the bottom there's clearly nothing growing, and even if I flip it over and pull the lid so you can get a good view, there's no growth on that plate. And this is 6 days at room temperature since casting the plate. And again, showing you this again, here is the wort agar plate, and you can see both from the bottom as well as from the top that there is no noticeable growth, again despite the fact that these are over a week old, almost a week old. So I hope you enjoyed this video. I hope you find it useful, and I'll see you next time.